what are the valid values, the valid digits for D. Okay. You remember from 2369, 0, 1, up to 7, right? So we can only use 8, the first 8 digits. What about hexadecimal? And hex, okay, and I'm just going to use the word hex, and this is perhaps the most important, after decimal, the most important way to represent numbers in computer programming, because it's a shorthand notation for binary. Okay. So we start. So in octal we started with a zero. Okay. In hex we start with a 0x. Okay. That tells us that, and it can be uppercase or lowercase. Okay. Tells us that what follows is a hexadecimal constant. And again, you put your digits, and here your digits are, D belongs to 0, 1, 9, A, up to what? A, F. Okay. So hexadecimal constant starts with 0x, D, and then these are the possible digits. It's important here to note that whether the same number can be represented with decimal, octal, or hex, right? That's, it's just a different base, okay? Remember, 2369. Okay. So as an example, okay, let's say I could define the following, a constant like as follows, okay? And actually, I can use these definitions here to define variables or constants, okay? So let's say int, okay, x is equal to 0xff. Okay. Or to be more since we're using 32 bits, okay, this is okay because basically all these zeros to the left of f are not necessary, right? But if you wanted to be very picky, okay, x is equal to 0x, and then you're going to have 32 bits because it's an integer. Actually, let me use a short to save some space. Short int, okay, x is equal to 0x, and then we need to put 16 bits, right? So it could be 00ff. That's 2 bytes, but again, these two are equivalent because they are the zeros do not count, right? Or you could do the following, okay, and let me put here short too, okay, just to keep the same example. You could do short int x is equal to 55, okay. ff is equivalent to in 0xff is in hexadecimal, the same as 255 in decimal, okay. So it's just different representations, and hexadecimal is very important for computer engineering in general, okay, and for programming. So at least it's always important to remember these two, okay, decimal and hexadecimal. I mean, hexadecimal and decimal are very important representations in programming. So probably we'll be using it a lot. Okay. We can also have a variable of type long, a constant. Sorry, this looks bad. Which will consist of D, and an L at the end. Okay. And basically, in this case, I forgot to say something. I'll come back to it in a minute. So in this case, we're saying, okay, all these values are to be represented internally as a long. Okay, so meaning that this implies you use 64 bits to represent D, whatever D is. Okay, D is we can have a hex, octal, or decimal. Okay, but still you can have this modifier to imply that the constant is long. Okay, or you could have the following. You could have unsigned constants. So here constant is referring to the actual to the actual value. Okay, so you could have unsigned constant. Okay, so this will be something like I'm sorry, I'm starting to not look at my screen, so sorry if I'm moving too much my sheet. And basically this implies that constant, as the modifier implies, constant unsigned is stored as an unsigned value. Okay, or basically when we go back to this example, okay, we have the constant 0xff, and that's going to be the initial value of x. And if I leave it like this, it's going to be a signed quantity. But I could add basically at the end something like u. Okay, so I could have x is equal to 255u, and automatically that's going to make it an unsigned quantity. Or I could have used L. Okay. One important thing that I forgot to mention is that here I'm using FF as uppercase, but it is also totally valid to use lowercase. Okay, so instead of FF I could have uppercase, I could have used 0xFF. Okay, so in this case the constants are not case sensitive. Okay, and basically we'll come back here, okay, to hex. Instead of using uppercase A through F, I will have to use lowercase a through F. Okay, so for the C compiler, it doesn't make a difference whether you use uppercase or lowercase hexadecimal digits. Okay, so to review again, okay, we have a constant here which is hexadecimal 0xFF or 0xFF, and this value is being moved into a variable x of type short integer, and these are two equivalent representations. Okay, and actually three equivalent representations, because 255 short int x equal to 55 is actually it's actually the same as FF. Okay, so let's see. So I think just to run a couple of more examples. So let's look at different examples of valid constants. Okay, so let's say we have a decimal, octal, hex. Okay. So we could have 143 minus 24,639. Again, we can have a signed quantity. Okay, minus. We could have something really long like 199,876 530, and I use the L to indicate it's a long one. Okay, I could have a minus 16924u, and the u here is kind of redundant, right? The u is basically telling us that it's unsigned, but yeah, actually this is a tricky one. Sorry, because we have a negative sign and then I'm saying that it's unsigned. So what's going to happen there? It's going to be a mess, right? Because we have a negative, but then making this unsigned. So that means that the bit sign gets converted into an actual part of the number. Hopefully remember from 2369 2's complement representation, right? That 2's complement, the most significant bit is used to define the sign. Okay, loosely put it that way. So it's not the same as having if this negative number, this negative sign has a meaning when you have a signed or unsigned number. So this is valid, but it's going